Hello everyone. In this short video, I am quickly explaining the solutions for this short quiz number 5 and short quiz number 6. It may not be possible for me to share the marks before tomorrow's class test, but I hope from the solution only you will understand that whether your answers are right or wrong, because it's a multiple choice question and you already have a copy of your answer sheet. So coming to the short quiz number 5, question 1. So this question has more information, like hit rate, right? Hit rate information is there. It's 97%, right? So miss rate will be 3%. And but these informations are not much important. Why? Because you need to find out the miss latency. You need to find out miss latency. So what is miss latency? Miss latency means first, as if there is a request coming to this cache, first it will search in this cache. Okay, after searching, if the block is not in the cache, then we need to go to main memory, and from main memory we need to fetch the block. So here the question is to find out miss latency, means only this latency, that you are first, you will come here, from this you will go to main memory. If there is a miss here, then you will go to main memory and you will fetch the data. So this is called miss latency. So if I want to calculate miss latency here, then what will be the value? So value will be 15 nanosecond for the first byte, for the first word, right? And 10 nanosecond for next words, right? So the total value will be 50 plus 15 into 10. Since there are 16, since the block size is 64 byte, right? So if the block size is 64 byte, how many words are there? 16 words are there. So first word will take 15 nanosecond, and remaining 15 words will take 15 into 10 nanosecond. So which is 200 nanosecond. Okay, so this is the actual miss latency. If there is a miss in the cache, then it will take this 200 nanosecond. But there was a small confusion in the question. That confusion is, some of you have added the heat time here. This 8 cycle also added, and you added the answer as 208 nanosecond. I cannot say this answer is wrong, because I have not, there is a small gap in the question, right? So you assume that the first you will access in the cache, so this is also considered as a missed time, right? So what I have decided that if your answer is either 200 or 208, I'll consider both as correct here. So if it is not 200 or 208, then I'll not consider this as correct. Okay, so I hope this is clear. Then we'll go to the next question number 2. So question number 2 is, I don't know why everyone did a mistake here. So if I go to question number 2, the first was MPKI is given, right? MPKI given is, what is the MPKI? MPKI given is 3.56. 3.56 is given as MPKI, and out of all the instructions, 40% instructions are load store instruction, right? So we know that load store instruction has two memory access, one memory access for fetching the instruction and one extra to communicate with the memory. So since 40% instructions are load store instructions, so we can say that memory access per instruction is 1.4, because if there is no load store instructions at all, then the memory access per instruction will be only 1 during the fetch. But since 40% are load store instruction, so I can say the memory access per instruction, let me write it here, memory access per instruction is 1.4. okay, so now MPKI is 3.56. so miss per instruction is 3.56 divided by 1000, isn't it? This is miss per instruction. So miss per instruction is, or what is miss rate? The question is about miss rate. So miss rate is memory, miss per memory access. miss per memory access. So here miss per instruction is 0.00356 and in memory access per instruction is 1.4. So it means that for every 1.4 memory access, the miss is 0.00356. For every 1.4 memory access, the miss is this. So for one memory access, the miss will be 0.00356 divided by 1.4. So this should be the miss rate. So why everyone did it wrong, I'm not sure. So since everyone did the mistake here, so I'm little bit confused whether I am doing any mistake, I am missing anything. So check this answer, and if you feel that this whatever I'm missing some point here, then let me know. But as per I cross check it, I think the solution that I'm showing here is correct, because I'm repeating it here. This is MPKI. If miss per kilo instruction is 3.56, then miss per instruction will be this divided by 1000. Okay, and 40% instructions are load store instructions, so it means that memory access per instruction will be 1.4. So in each instruction, memory access are 1.4. So if I combine this line, miss per instruction is this, then it means that for every 1.4 memory access, the number of misses are this 0.00356. So for one memory access, what will be the miss? Miss will be this divided by 1.4. So this means that this circle means that miss per memory access, which is actually the miss rate, right? So I think this question is not correct. The answer is not correct. For almost everyone did wrong here. But let me know if I am missing something here. Okay, so this is for these are the two questions. I have already explained these two questions. Now let me move to short quiz number 6. Short quiz number 6 is I think if I am not wrong, I have written the answers here. So the answer of first question is B, C, D only, I think. Yeah. So let me check it from here. A cache-friendly application do not get benefit from LRU replacement policy. This is wrong, right? A cache-friendly application take the maximum benefit from LRU replacement policy. Okay, so A is wrong. Pre-charge operation is not always required before accessing a block from the DRAM based main memory. That is correct. Why? Because if as I said, this is your DRAM structure, right? And if this row, you activate this row, your data is available in this row buffer, right? And after this, if you want to read multiple columns from this this row, then all will be hit in the row buffer. So during this, suppose you want to read row 1 column 1, row 1 column 2, row 1 column 3, then for these three read, you no need to do any pre-charge, no need to do any activation, because first one is not Rohit, the next two will be the hit in the row buffer. So I think the step to B is correct. C says replacement policy in set associative cache is applied to each set independently. Obviously, this is a very straightforward point. A larger cache block size improves the spatial locality but may generate more conflict misses. I have explained this in class, right? I don't think it is required to explain more here, because if you go with larger size larger block size, then you will fetch more neighbor words also. So it will improve the spatial locality. But if you increase the block size, it means that the number of blocks that you can place in the cache will reduce, right? So that may create conflicts, more conflicts. Okay, so B, C, and D are correct. E says set associative cache has fewer conflict miss compared to fully associative. No, that is wrong. Fully associative has 0 conflict miss. Write through policy write back dirty block during block replacement. No, that is false. Write back policy writes dirty. That is called write back policy. Write through immediately writes the dirty block back in the lower level memory. So E and F are false. DRAM technology has low density than SRAM technology. That is also false. DRAM technology has high density, almost 8 times higher density than SRAM technology. The row buffer of DRAM memory also need to be refreshed like DRAM rows. That is again false, because the row buffer are kind of designed with SRAM technology, and they no need to they do not require any refresh. Okay, the dynamic partitioning technique are used to remove dead blocks early from the cache. That is also not correct. Dynamic partitioning are used to fairly distribute the last level cache among all the application, but it has no direct connection with dead blocks. So only B, C, D are correct. There is no negative marking here, but there will be no partial marking also. So if you can check the questions, you can also get the marks that you will get from this quiz. So correct answer for question number 1 is B, C, and D. Okay. Question number 2, both are wrong. This is the correct answer. Larger cache size can reduce compulsory miss. That is wrong. Compulsory misses will be same even if you go with infinite size cache. Okay, so statement 1 is false. Reducing miss penalty can reduce number of misses. That statement is also false. If you reduce the miss penalty, right? If you reduce the miss penalty, it means suppose this is a cache. If you reduce the miss penalty, means suppose you have designed main memory in a very efficient way and access time reduced. But if that access time reduced, then it has no direct connection with number of misses. So both statement 1 and statement 2 are false. So the answer is both are wrong. And the same thing here in question number 3 also, the answer is both are wrong. Here also statement 1, direct map caches no conflict misses. Direct map caches the most highest number of conflict misses compared to the 3 cache structure that we know. Set associative caches no conflict misses, that is again false. Fully associative caches no conflict misses. Set associative cache have the conflict misses, right? So these are the 3 questions. So I hope I have explained all the question. Only doubt is in question 2 of quiz 5. So let me know if I have missed something here. So I'll not share any marks tomorrow, but I hope you can cross check your responses, because when you have submitted the quiz, one copy of that quiz is emailed to your inbox also. So that's check the responses and you can easily calculate how much marks you are getting from these 2 quiz. Okay, so I'm stopping this video here. Thank you for watching.